All right, day 3 in 5, 4, 3, 2, 1. We are live. Okay, one elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packaging instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase letter or uppercase letter. That is, A and A refer to different types of items. The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. Bunch of junk. The first rucksack contains the items, bunch of junk, which means its first compartment contains the items, bunch of junk, while the second compartment contains the items, bunch of junk. The only item type that appears in both compartments is the lowercase p. Okay. The second rucksack's compartments contain blah and blah. The only type that appears in both is uppercase L. And then so basically we're looking for in the first half of the string and the second half of the string for something that happens to be in both. So like the second one or last one here, half's about there, lowercase s, lowercase s. Okay, so there's a few ways to do that, but first let's just grab our stuff here, and then let's go throw that into test file, and then let's also oh, there's more, dang it. To help prioritize item rearrangement, every item type can be converted to a priority. Uppercase item types A through Z have priorities 1 through 26. Uppercase items A through Z have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is 16, 38, okay. The sum of these is 157. Okay, so that's how we get our answer. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? All right, so we'll have to do 2 problems here, but that's no problem. Okay, so let's get our puzzle input as well. And then we can close day 2. Okay, so basically we're going to want to take everything in as individual strings, no problem there. We're also going to want to have a total list of priorities. And then in the end we're going to want to return that priority total. And then we're also going to want to have a separate function for, say, calculate priority, which will take in a car C, we'll call it, and return a long. I am losing my mind. Okay. So the first thing we need to do is we'll need to split the each line into its own 2 halves. So for line in input, should be familiar right now, and then we're going to do basically we're going to make 2 substrings. So val stack 1 is going to be equal to the line dot sub string, so we'll do 0, and we want line dot length So if it's a 2-item list, then it will be 0, 1, 2, 3, or 0, 1, and then this would be 0 to 1. And I believe, let me double check. I believe that does not include the last index, ending right before the index. Yeah. Sorry, you can't see the pop-up, but it's basically going to start on the first one and it's going to end the character before that one. So that's easy enough. And then we're also going to do sac2 is going to be line dot, we'll just do substring, same thing, and then we'll do line dot length over 2 plus 1 because we want to start one higher. And then we'll do it line dot length. I think we need 1, sure. That may cause an overflow, or it'll all be obvious. Okay, so now we have our 2 substrings. The next thing we're going to need to do is just compare which ones are common. The easiest way is probably just going to be for C and sac1, if sac2 dot contains C, and this should already be a character because if you do a iterative loop inside of a string, it's just going to do it by character type. So we don't even have to like bother with string structure or anything like that. So if it contains that, then we'll say priority total plus equals calculate priority. Oh, yeah, because they don't do this in class form, I have to put this first. C. And so basically, I think that's all the logic we need for this part. The only thing we need to do for the calculation part is try to figure out what the numbers should represent. And so if we look back at here, A through Z is going to be 1 through 26, and capital A through Z is going to be 27 through 52. So if C dot is uppercase, then we're going to want to add 26 to whatever we get. And then if, regardless, we want to do priority plus equals C dot to lowercase, and then we need to convert that to an int. And then the ASCII of lowercase a so the ASCII of lowercase a is 97. So, and that, we want it to be a 1 for an A, so minus 96. And then return priority. We could probably just return from here, but that's fine. And then let's see what our total is supposed to be here. 157. So we'll put 157 in, and then we'll run this and see if it works. I'm sure I broke something. Did. Yep. So begin 13, end 25 on a length of 4, or 24. So that's what I was thinking before. I think this one should just be there. And they still, the other two may still be off by 1. Yeah, so I think what we want to do is, so let's verify that that is correct here. Oh, I don't want that. So the first input is on test V to WR, and then HC. Okay, so these are correct and they're obviously the same length. So then the next part would be to double check that our total is correct. Yeah, so the first one is supposed to be a lowercase p, and that's what we got. And then p is supposed to be a 16, which is what we got. And then 38, and then 38 again. Okay, so my guess is there's two L's in here. Yeah, so we need to break on this. Beautiful. All right, so 7691. Let's go try that real quick. And right answer. Okay. Move to part 2. After you have finished identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of the 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have the item type B somewhere in the rucksack, and at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put all of this year's updated authenticity sticker on the badges. All the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines. Are these the same lines? They are the same lines. They just didn't put a space in between. Okay. And the second group's rucksacks are the next 3 lines. In the first group, the only item type that appears in all 3 rucksacks is the lowercase r. This must be their badges. In the second group, their badge type must be a Z. Priorities for these items must still be found to organize the sticker attachment efforts. Here they are 18 and then 52, some 70. Find the item type that corresponds to the badges of each 3 elf group. What is the sum of the priorities of those item types? Okay, so basically same thing, but now instead of looking for halves, we're looking for across 3 different strings. So, and since all 3 strings have to contain the badge and nothing else, we can assume that if the first one has a letter and the other 2 both also have that letter, that must be the badge. And if the first one's not contained in either of the other 2 rucksacks, then it cannot be the badge. So we actually can do pretty much the same exact logic. But what we'll need to do is basically we'll have to do the lines in groups of 3. So our for loop will be slightly different. So this is just a neat little Kotlin trick. This basically creates a range. So basically I'm saying I want everything between 0 and this number as an int. There's also some tricks where you can do it like by steps and stuff like that as well. So basically this is going to create a collection, and then that collection is going to have like 0, 1, 2, 3, all the way up to the number of elves divided by 3. It just allows us to do some really interesting tricks with that stuff. And then basically what we're going to do is sac1 is then going to be input of I. Sac2 is going to just be input of I plus 1. And then sac3 is just going to be input of I plus 2. And then again, because it has to be in all 3 sacks, if it's, or for everything in sack 1, if sack 2 contains it and sack 3 contains it, then we want to add to it. Otherwise we don't. And then our expected value, it should be 70. And let's see if that works. Check failed. Okay. Oh, yep, that's my bet here. This should be multiplied by 3. So, because we're increasing, or we're doing the bags by 3, Z, R and Z, index 6 out of bounds. Yeah, another thing you can do is until, so basically ignores the last value. Again, just a little Kotlin reader thing. Okay, so the check failed again, but it found badge with R and it found badge with Z, which is what we wanted. So why is it failing? Oh. Oh my gosh. I completely just wrote over part 1 instead of putting it in part 2. Great. Super smart. Okay. 2508. Easy enough. Let's go down here, paste it in after wasting 2 minutes. Okay. That's the right answer. You completed day 3. Cool. I guess I will see you guys tomorrow.